Okay, welcome everybody to Data 8. We are officially here, first day. Yeah, go Bears. Nice. Excited to be here. So, quick intros here for some of the professors. So, maybe John, if you want to go first.
Sure, I'm John Tadiro. Was a graduate student at Berkeley long ago, fell in love with the place and have never really left. I did my PhD in computer science. I actually did sort of leave. I went to work for Google Translate for a while, but I was teaching here on the side, so it's hard to get rid of me. I came back to Berkeley, well, to teach computer science. That's what I knew. But things got really interesting when I started teaming up with folks in the statistics department and across campus to help create Data 8. So I got to be part of that kind of founding group and really enjoyed teaching this course. So I'm thrilled to be back teaching it again. It's actually been a little while since I've done it. Yep, that's me. Swapnil, over to you.
Sweet. Yeah, everyone, I'm Swapnil Sahai. I'm not the other Professor Sahai you might know about. So I also went to Berkeley for undergrad. So back then I graduated in 2013. So I did like math and stats and econ. So there was no data science major, sadly. I got my PhD in statistics from Columbia. So I went out to New York, greatest city in the world. Came back out, worked at Tesla Autopilot. So I was working in autonomous driving for a while, doing computer vision, which is basically just a fancy way of saying detect stuff using cameras. And then started my own company. So I have a startup now that's also doing computer vision, but in the sports space. So if you play sports and you're into like data science and sports, definitely reach out to me. You would definitely love what we're working on. And I'm still doing that today, but have found a way to kind of squeeze back into Berkeley, kind of like John did back in the day. And just really thrilled to be at Data 8. So this is my fifth time teaching Data 8. So super excited about that. And yeah, I feel like a five-timer on SNL. So it's pretty cool. But yeah, maybe, I don't know, John, if you want to do a little bit of a little question answer session here.
Yeah, well, that's cool that you have a startup and you teach. Is it something that you always wanted to do, to mix the two, or did it just kind of come out that way?
No, definitely not. I never thought I was going to do a startup. I've always been like super risk averse my whole life. But I had this idea and I wanted to pursue it and I wanted it to exist. And so just kind of willed it into existence. But I've always wanted to teach. That's something I was actually a GSI for multivariable calculus, Math 53, back when I was in Berkeley. So I've loved teaching since then. So I knew I always wanted to come back and do that. But yeah.
And
I,
you taught Data 8 for a while, but then you went and taught what probability Data 140
yeah.
last semester, and now you're back. Did you miss Data 8, or what are you doing back here, man?
Yeah, I definitely miss Data 8. I mean, 140 was a good experience, but I love Data 8. I love how big the class is. I love how diverse the students are. And I love all the memes because the students are so good at making memes. And I'm going to hold you guys accountable. You guys need to set the bar even higher with the memes there. But that's my favorite part for sure. How about you, John? You've taught so many classes. I mean, obviously 61A, and what's been kind of your experience in teaching that versus like Data 8?
Well, Data 8, I think, don't tell the other classes, but I think the student population that comes into Data 8 is the most interesting group I've ever met, because they're coming from all over campus, lots of different perspectives, and the material in Data 8 really makes you think, not just about technical stuff, but about the world. And so I think that's cool. Now, of course, the folks who come into other courses that I teach are really interesting too, but there's just a really special mix of students that come into Data 8. And so, yeah, I think that's pretty great. And, there's a Q&A here as well. So if you have questions for us, we'll try to answer those. We have a third person with us today, which is Will Furtado. You want to introduce yourself, Will?
Sure, yeah. My name is Will. I'm one of the lead GSIs. So I'm specifically pedagogy lead, so I'll be coming to all the lectures, helping answer questions, things like that, monitoring the chat. Yeah, I'm a junior. I study math and CS, but I've been on course staff for Data 8 for my whole time at Cal, and I really enjoy it. So yeah, if you have any questions, feel free to email me. My email is on the course website, but yeah, you can also say stuff in the chat, but I'll be here.
Yeah, your Twitch mod for Data 8, basically.
So like he'll answer a bunch of the questions on Q&A and chat, but then if there's anything that he thinks that we should answer, then he'll let us know, and we'll try to do it live.
Yeah. Cool. Sweet. And then besides Will, we have an amazing staff here. So you can check out the full staff here on the website. We have a ton of staff members here, just kind of keeps going. So this course would not be possible without the staff. You'll be interacting with them a lot in your various sections and office hours, and hopefully get to know all of them really well. And all the staff are kind of past alumni of Data 8, taken it, slowly progress their way up in the staff, and so we hope you guys will also, after this class, come back and help future students. It's a great community to be a part of, and they're really awesome. So we hope you have a good time with them. Cool. So a bit about Data 8 and data science. So Data 8, first of all, is, I think, the fastest growing class in Berkeley now, and it's, I think, the second biggest class. John probably knows if that's correct.
This semester, Data 8 is the largest course on campus. Right wow. Now, this Zoom session, we have almost 1,400 people. Yeah, CS61B is also big, but we're like 12 students larger. So we're the biggest one. Wow. And I don't know, I think this might be the first time that Data 8 is the biggest course on campus.
Yeah, that is definitely true. Yeah. Wow, that's cool. I didn't know it was #1 this semester. That's cool. Okay. Well, yeah, so that's really exciting. So I mean, this is a big class. It's, it's been taught in a very innovative way, I would say. Traditionally, when you've thought about data science, it's been kind of reserved for folks with a really technical background. And at Berkeley, we basically took the approach. When I say we, basically, I mean Professor De Niro and Professor Adhikari, who started the class. They basically took the approach that everyone should be able to reason with data. And we don't just want like a homogenous set of people in this field. And so that was kind of how this class was created, how the entire major was created. So it's really, really exciting. And, why are you taking this class? Because basically data is kind of everywhere, and it's really important to be able to make decisions from the data. And, you make decisions in your daily life based on data, but even just in your work. And we want to make sure that the insights that we get from this data is determined and influenced by a diverse set of experiences and backgrounds. And so that's kind of really the goal for us. And so in this class, what we're going to basically be doing is trying to learn about the world and reason about the world using data and computation. And so when we say computation, we basically mean manipulate data with code. And specifically, we'll be doing that with Python here. And so someone mentioned, do we need to have prior coding experience? So you don't. This class is designed so that you've never seen code in your life before, and you'll still be able to take this class. That's really how it was designed and why it was made. So no worries there. If you haven't coded, that's in fact going to be better, and you're really going to enjoy the experience, I think. And there's basically kind of 3 sort of components that we'll be having in this course. So when we have data, basically, if you have a data set, it's super messy. It's just like, think of it like a cloud. Like it's just this like swirling cloud of just glob and mess, and it's really messy, and we want to explore that. And so how do we do that? Well, we try to find patterns. And one way that we try to find patterns is we take little snapshots of the data from different angles. And so you have this like swirling cloud, and you try to like zoom in and take like a little simplified picture. That's essentially data visualization. So we'll learn how to make data visualizations. Once we do that, once we see some patterns that are interesting, then we're going to try to make some conclusions from the patterns. And so, typically when we have data, it's going to be like a small subset, a small sample or something like that. And the idea is going to be, can we take that small data set and make conclusions about the larger world based on what we're seeing? And so that's what inference lets us do. And then the tool that's going to let us make those conclusions is statistics. So the whole idea with statistics is that you can't observe all the data in the world. You have to observe some smaller set of it, but you can still make reliable conclusions using these tools. And then lastly, towards the last part of the course, we'll go over prediction, which is also using a small set of data, but making guesses about data that we haven't observed yet. And then we'll kind of conclude the course with going into some topics in machine learning, which is basically just a fancy way of saying your computer does a lot of these predictions for you, but we program it ourselves, so it's not completely automatic. So that's going to be the main kind of components of the course.
Yeah, there was a question in the chat or in the Q&A about like having prior CS experience, is that valuable to learning data science? And if you look at that array of different things that we're going to cover in this course, I'd say most of them aren't about just programming, but you do need to learn to program in order to carry out a lot of the things that we're going to do. And so this is a course where we don't teach you tons and tons of topics about programming. Instead, we teach you the really important stuff and give you a way to practice it, which is to do exploration and inference and prediction. So knowing how to program in advance means you don't have to learn it here, but it's not a prerequisite at all. Instead, mostly what you'll learn is about understanding data, thinking about what the data tell you and what they don't, through these ideas of exploration, inference, and prediction. That's mostly what this course is. It's not really a programming course, but you learn programming as a byproduct so that you can use it to do all these things, because it's a really powerful tool. So in my particular case, like, it was nice to have already known how to program, but I don't think that was really sufficient to get into data science. I had to do a lot of learning myself in order to understand what's in this course and the future courses. And I think other people will too. So if you program already, that's fine, but it's not going to really help you understand the core concepts here, because there's a bunch of new stuff to learn.
Yeah, thank you. Yeah, exactly. And basically you can think of the programming part as it's almost like a tool for learning the main concepts. And then the concepts will be somewhat similar to what you might find in a statistics course. We're not going to cover everything that you'd see in a statistics course, but it's kind of like some concepts from there will be used, some concepts from coding and computer science will be used as well. But the idea is you don't need to have any prior experience in either of these areas. We're going to be very intentional about making this super accessible. We're going to try to use plain English whenever possible, avoid fancy words and formulas, and really just make it super accessible, and still make it so you can have a powerful way to understand and reason with data. Cool. One question was about, are we going to be meeting in person? So that's kind of up to the campus policies. As of now, the plan is in 2 weeks, we would go back in person. So assuming that stays the same, then yes, we will be back in person in Wheeler. So it's going to be awesome. And so, just fingers crossed and everything goes according to plan there. Oh, this is a good question, actually. How are inference and prediction different? So we'll go into more detail about this throughout the course. But basically, when you're talking about inference, you have kind of certain, I guess, properties about individuals that you can already observe. Whereas with prediction, there's certain properties that maybe you can't observe. So like, let's say I'm trying to figure out what's your height based on your weight or something. Like I can't observe your height maybe for some reason. So that could be one way of doing like a prediction. Whereas with inference, you typically have all the properties you want available, but you're trying to make a statement about a larger population. So the kind of data set itself is sort of the same, but you're just increasing the scope when you're talking about inference effectively. But we'll go into more details about that. Cool. So next up, we have the course website. So this is kind of your source of ultimate truth. So bookmark this page. You'll be checking this regularly. So here's what the website looks like. So up top, you'll see announcements. So we'll have basically a new set of announcements right before every lecture. So like 3 new announcements a week. They won't change that much, but they'll typically be just announcing like new resources that we've posted, or if we have a homework due, you'll see that here. If we have like a project due soon, you'll see that here. So this is kind of always check out the announcements. And then below that, we have the calendar. So this is going to just show you what we're going to cover every single day. And then we'll typically upload the slides and the demo. So the demo is basically just the stuff that we're going to do in Python, because we will be coding live in Python during the lectures. And so you'll be able to see the demos here. You can click this and just open it right there in your web browser. You don't need anything else to do that. It's really convenient. And we really encourage you to open these demos because then you can follow along as we're doing it. So the last part of the lecture, Professor Dinero is going to be doing a demo, typing out Python live. And so you can follow along if you click this demo link from the website. And then once the video is available, then we'll also add the video in this section as well. So if you're not able to attend for some reason, then you can always watch the video later. And then we'll also have kind of what reading is covered for that lecture. And then if there's like worksheets that come out for lab, we'll explain what lab is in a second. And then assignments as well. So all these things will become sort of like clickable once they're released. And then there'll be due dates assigned to all of them. So that's like the general web page that we have. And then also you can check out the policies. We have a few additional tabs up here to just learn more about course policies, the staff page, which we showed you before. And then also we have office hours where you can see more information about that.
And now is probably a good time to answer this Q&A, which is this course very fast paced, and is it recommended to use extra practice outside of class to get to know the programming language better? I'd say, look at this table in front of you. The best thing to do is actually interact with everything that's there. If you come to lecture, if you work through the demos afterwards to make sure that you understood them, if you do the reading and you do the lab worksheets and you do the assignments, now you're going to learn the material. That's how it's designed. So rather than thinking of what extra practice can I do, I would definitely think about, oh, I should actually do everything that's in this table, as opposed to just picking and choosing the parts that I'm in the mood to do at the moment. That tends to be a recipe for success. So yeah, do the reading and do all the assignments and really focus when you're doing them. I think that's the best way to approach the course. It's not designed to be fast paced, but we do have a lot of different activities. They're all on this table. And so now you have a sense of everything that you'll end up doing when you take the course.
Yeah, I mean, another thing I like suggesting also is, not everybody has the schedule for this, but if you have the ability to do the reading before the lecture even, right? That's also a nice way to just kind of get a little bit introduced to the material before you come in. And then that way the lecture won't be the first time that you see the material. So, not required, but I think it does kind of help add a little bit of context sometimes. And then you can come in with some questions already that you might want to get answered. And so you can be like really efficient with how you take advantage of the lecture time. Cool. All right, so let's just go over the components of Data 8 because there's a few to kind of discuss here. So one is obviously lecture. So, please come to lecture, ask questions. We'll definitely stop for questions like we just did. And we'll also have opportunities for more interactive discussions, especially when we're in person. That'll be really cool. So why don't you stop and have you like discuss with the person next to you and things like that. And then we will record lecture, as I mentioned, but it's always gonna be better to attend live just because you can ask questions and kind of guide the course of how it follows. We also have our textbook. This is free online. It's written by Professor De Niro, actually, and Professor Adhikari and other founders of the course. So you can just check it out. Some of the slides directly. It's also linked from the website. And so that's completely free online. Nothing special there to access it. So that's going to be a great resource as well. And, lecture won't cover necessarily everything in the textbook in as much detail because we do have limited time. So definitely check out the textbook to kind of go deeper into the examples. And then we'll also have weekly lab sections, which are going to start this week. So what is lab? I guess a question for you guys, when I say lab, like what comes to mind? When I say like a lab, what do you guys think of? What image like comes to mind? Hands-on, experiments, beakers. All right, so we have almost all of those things, minus the beakers and titrations. So it is very hands-on, it's experimentation. It's basically, in this sense of data science, it's like where you can play around with code, where you can play around with data, and just learn how to code, learn how to mess with data effectively. That's what it is. And so it's just gonna be a really great opportunity for you to play around, try things, break your code, break your friend's code, learn from each other. And just get really familiar with Python basically and all the data that we're going to be manipulating in this class. And so we're starting that this week. So please attend that this week. And it's going to just be a great opportunity for you to just even collaborate and just kind of get to know other people in the class. We'll also have weekly homework assignments. So one assignment a week. And then we'll also have 3 projects in the semester. So these are kind of evenly spaced out throughout the semester. And then office hours will begin next week. So we'll have a schedule online where you can check the times and locations of the various office hours with the GSIs. And then the professors will also have office hours, which we can maybe share. And we'll post it on the announcements as well. So you'll see once we announce the office hours for our individual office hours. So feel free to come to our office hours, the GSI office hours, whatever works best for your time and your schedule. And then last couple of things to mention, we have our midterm. We have one midterm. It's going to be Friday, March 11th, 7 to 9 p.m. Pacific time. And then we have the final exam on Tuesday, May 10th. So those are the main kind of components of the course. And, you can look in the policies to learn a little bit more about what's kind of the breakdown between them and all that, but that's the main components of the class. Cool. Any other questions?
There are a lot of questions. I'm trying to keep up. So most of them are administrative. We'll answer over text. But the most important thing is the lab is this week, so you should go. And how are labs graded? Well, you can take a look at the policies, but you got to come to a few lab meetings, especially this week. Attendance is required. In order to get full credit, you got to come to 5. But you also need to complete the lab assignment. So the best way to do it is to go to the lab session, and then you can just complete the lab assignment while you're there.
This is a good question. Do you need a calculator? You will not need a calculator. Most of the time, you'll have access to your laptop. So your laptop will be your calculator when you're in Python, when you're coding in Python. And then if you're doing like a written exam, then we won't really require a calculator. You can just kind of leave answers in whatever expression, mathematical expression you have it. So yep, don't have to worry about that.
And if for some reason we never get to your question in Q&A during this lecture, I would strongly recommend that you post on it and get some help that way.
Yep. And then maybe last question I'll just answer is Python the only language you will code in? Yes, that's the only language that will be covered for this course. So don't have to worry about anything else for this class. Actually, sorry, I'll answer this one too. Do we need to download any software for this class? You do not. So we've done it so everything is just going to be in the browser. So like all the slides are in the browser. The Python coding will be in the browser. Your homework assignments, projects, those will all be done basically in your browser window. I guess the only software you would technically need would be Zoom, but that's basically it. Cool. All right. So a few notes on collaboration. So asking questions, greatly encouraged. And we especially encourage you to work with each other, discuss with each other, other than exams, pretty much everything else, we encourage you to discuss questions with each other and just discuss like ideas. And then basically the way it'll work is for lab assignments, you'll submit those individually, but, welcome to discuss together during lab. Homework, again, same thing, submit that individually, do your own work, but feel free to discuss questions and ideas. And then with projects, the way it'll work is those 3 projects that we have in the semester, you'll either work individually or with a partner. It's kind of up to you how you want to do it. We highly recommend working with the partners because it's, again, nice to just exchange ideas and also get to know someone else in the class. And then there's obviously some limits to the collaboration. So don't share solutions with each other. The only exception to this is the project where you're actually working together as a team and doing one submission together. In other situations, please don't share solutions with each other. And then just have to say this, but copying another dishonesty will result in severe penalties. And, we've had to do in the past, it's not fun. So please don't make us do this. You shouldn't feel the pressure to do this either. We tend to be pretty generous with the grades for this class. So we just want you to focus on just enjoying the material, learning the material, and don't feel pressured that you feel like you need to get to this point. So, but otherwise collaboration is great. That's kind of the essence of data science, is having different people from different backgrounds and disciplines and majors all talking together, exchanging ideas. And so, highly encourage that, and make a conscious effort to meet someone and work with someone who's not in, pursuing the same major that you are, or, has a very different background from you, because you'll learn so much more the more different someone is from you. So that's one tip I would say, is just try to seek people who are different from you. And I think you'll get a lot more out of the class. Cool. And in terms of getting help, so let's say you're stuck in the class. I think general tips I would say is, first step would be try to ask a friend, ask someone you know in the class. Maybe it's someone that you just met in your lab section and you don't know them that well, but you know their name. Start with that, reach out to them, ask them, try to come up with, a solution or at least get past your question by talking with your friend. If you guys are still stuck, maybe try asking on Ed. That would be, I think, the next great place. Asking Ed is really nice because it also gives other students a chance to respond. And then you also will get responses really quickly too. Because if another student happens to know the answer to the question, then they might respond much faster than a staff member. So you might actually get the response quickest this way. And then you should also try answering other people's questions on Ed, because that also reinforces your learning of the material. And then if you're still not able to get anything answered on Ed, then come to office hours. And then if you still need help after office hours, we also do have tutoring sections as well. And we'll explain more about that later. But we'll definitely have lots of resources basically to kind of get help whenever you're stuck anywhere.
There was a question, what's ED? So
yeah.
Similar to Piazza, it's a forum, and you can go, if you go to data8.org, there's a link to ED, or you can go directly there. You should all be enrolled. Yeah, let's learn Swapnil's password here.
Oh God, let's see what happens. Oh, okay, there we go. Touch ID. So close. Y'all almost had me. Do you have to authenticate?
Yeah.
There we go. All right, that's not too bad. All right, so here's Ed. So yeah, you can basically start a new thread here if you want to ask something. What you should also do is try to look for an existing thread, because, for example, there might be like a thread on a particular homework assignment or a particular like question. So you can definitely check it out. So this is, for example, a thread on Lab 1 worksheet notebook. So this could be maybe a good place to like ask follow-up questions. So you can do that here with comments and things like that. So play around with this a bit, but basically it's kind of like a thread, threading, I guess, platform. Sadly, there is no mobile app. I know it's really sad. Hopefully they're making one, and I'm sure it's in the works, but it's just browser-based right now. So it does work pretty well in the browser, even on your phone. So at least there's that. Cool. All right, so I guess next up we have course policies. So maybe I can end my screen share if you want to take over, Professor Danira. Oh, and I believe you're muted.
Okay, nothing worse than dead air time. Well, anyway, here are the course policies that you really need to know about. First, the purpose of this course is for people to learn things that they don't already know, not to just show off what they already learned, demonstrate that they've already taken a bunch of prior classes, and race through the material. So for that reason, I would strongly encourage you to help each other learn and never be discouraging to other students who are still in the learning process. If somebody doesn't get something already, that's like totally normal. And if you don't understand something yet completely, that's totally normal too. So a lot of our course policies are designed around making sure that you can go through the learning process as opposed to already knowing everything the second that you finish lecture. And one of the most important parts of this course, one of the reasons I love teaching it, is that if you help each other learn, then you begin to form community. And yeah, like Swapnil said, if you can learn to teach each other, help each other, work with each other, and collaborate, you'll get a lot more out of this course. And I think you'll probably remember it more. And you'll get the value of learning the course material, but also maybe building some relationships with people that you'll work with later on in life. And the last part of the course the course policies I'd like to mention is that the course staff are here to help you be successful. They're not here to see whether you're, clever enough to study data science in the future or to give you a hard time. They're really your allies in the learning process. I hope you treat them that way. And I hope you, therefore, are willing to come talk to the course staff whenever you're feeling stuck or wondering how to proceed, because there's quite a few. They're really talented folks, and they're really dedicated to making sure that you can be successful in this course. And you have to do it too. They can't make you successful without your contributions, but they're definitely there to help. There's also a long list of course policies, and you can read. So I saw a bunch of questions, we're trying to answer them. But the first thing I would recommend is just read the course policies page. Probably some of your questions will get answered there. And if you have questions about that, just post on it. Okay, we're going to use the rest of the time to do an example of data science, because why not? There we go. So let me tell you what I'm showing you at the moment. This is something that you will have access to. It's a browser-based computing environment where you can write programs and run them, but they don't run on your computer. Instead, they run on a computer that's managed by Berkeley. And why do we do it this way? Well, this is mostly how data science is done in the world. Instead of having the resource constraints of your own individual laptop control the size of the problem that you can work on, instead, people use an interface like this in order to run their code. Sometimes it's running on their own laptop, but oftentimes elsewhere on some like cloud computer, or maybe even a group or cluster of computers, so that you can scale up the amount of computational power you have along with the size of the problem that you want to solve. Now, in Data 8, we're not going to solve any huge problems, but it just makes it a lot more convenient because you don't have to install anything to use this kind of hosted computing environment. And it says Jupyter up here in the corner. This is a Berkeley project founded and led by a statistics professor named Fernando Perez, but it's used all over the world. It's the main way that people kind of work with, do data science in kind of a cloud computing environment. So how could you get here? Well, you can go to datahub.berkeley.edu. And after you click through some authentication stuff, you'll see a bunch of files. Now, yours might be empty at the beginning. You could create something new, but what I would recommend is instead you start working with one of the examples from the course, and you find those on data8.org. These links will bring you to our cloud computing environment and load up an example from the course. Okay, so you can do that or you can't, but okay, so I'll let you play around with that later. You might as well just take a look at what I'm doing now. So computing environment means that you can write programs. Simplest kinds of programs are just mathematical expressions. And this is called a cell. This is a place where you tell the computer what you want to compute, and the output is the value or result of that computation. Instead of spending a lot of time just adding numbers, we're going to primarily be working with real world data sets in this course. So how do we get there? Well, first of all, you have to set things up. And here is maybe the scariest moment in the whole course for people who haven't programmed before. You see a bunch of text, none of it makes any sense, and yet it needs to be there for some reason. So let me just tell you that there will be a block of this kind of thing at the top of every notebook, and you should ignore what it says until one day you might want to learn about it, but it's not important. What is important is to know what it does. What it does is kind of set things up so that you can be productive. So every time you have a cell full of code, you can run that code, and all running code will do here is just set up your computing environment. We haven't done anything interesting yet. And so I'm not going to try to explain what's here because I'm telling you, it doesn't do anything except for set stuff up. Here, we're actually going to do something. What we're going to do is read the text of two books. So these are copies of text from what's called Project Gutenberg, which is a repository of all the books that are in the public domain, which means that you can use them for whatever you want and paste their text on the web because they're out of copyright. Pick some old books, before 1925. Huckleberry Finn by Mark Twain, Little Women by Louisa May Alcott. And, we could read these books ourselves, but wouldn't it be easier if the computer read it for us? So it did. And I used a little shortcut there. Instead of pressing run, I held down shift and hit return or enter. And that's how I executed this cell. So now something's changed. Now there's a little number here to tell us that it ran. And I've actually gotten the chapters of Huckleberry Finn into my local environment. And here they are. So these were pulled off of the web. And there's a little bit of stuff that's about the programming language. You'll learn about that. But most of this is really just the text of the book. You don't know about me without you have read a book by the name The Adventures of Tom Sawyer. Okay, so Huck Finn was written after The Adventures of Tom Sawyer by Mark Twain. And here's the text. Computers don't understand the text, but they can certainly hold the text and show you the text. They can do a bunch of other stuff with the text as well. Like, for example, we've broken this up into chapters, but we can only see the beginning of the first chapter. And that's because we haven't put it into a convenient format. So a lot of data science is manipulating data from whatever form you start with to the form that's actually convenient for you to do something with it. So one thing you'll learn about in this class is how to put data into tables and then work with those tables. So here's all the Huck Finn chapters that I had before. And now I've put them into a table. You might have a dozen questions. Why are there parentheses here? What does this dot mean? We're going to cover all of that. So today, we just want to do something interesting. So I'm not going to explain every detail, but eventually you will know all the details of why these things are the way they are. And I think that's part of learning to program. But in order to learn, you first have to know kind of what you're after or what your goal is. And so that's what today's demo is about. Okay, so we got this first chapter. There's a second chapter. We were tiptoeing along a path, etc. And now we have a more convenient way to read the beginning of chapters, but we haven't really learned that much about the book. Well, what could you learn about the book? Doing something simple. Computers are good at repeatedly doing simple things, and sometimes that can lead to interesting insights. So one thing we could do is we could count the number of times that a particular word showed up. Apparently, it's really important to read The Adventures of Tom Sawyer, so maybe we should look up how often Tom Sawyer shows up. We've asked the computer to count the number of times the word Tom appears in these chapters. Now we're getting a number for each chapter. Tom was mentioned 6 times in the first chapter, 24 times in the second chapter. Okay, and then for a long time, he wasn't really mentioned at all. Why is that? Well, this is a book about Huckleberry Finn, not about Tom Sawyer, except then Tom Sawyer does show up and like the real action and adventure begins. And you can actually kind of see that pattern just by looking at numbers. So part of data science is about using a way of computers to observe things about a data set and then drawing your own conclusions based on those. And that's kind of what we're doing. Okay, so what's another character? Jim is Huck Finn's traveling companion. So, you know, it doesn't get discussed much in the very beginning, but then he's part of the whole book and shows up a whole lot more than Tom Sawyer ever did. And then there's Huck as well. So, you know, looking at a long list of numbers can sometimes lead to insights, but Swapnil mentioned that a big theme in this course is about exploration through visualization. Oftentimes it's easier to see what's going on in a data set if you build a visualization of it. So let's do that. Let's build a table where we have for each chapter how many times Tom was mentioned, Jim was mentioned, Huck was mentioned. We'll call that counts. And now we can see, this is chapter 1, chapter 2, chapter 3. All of the different counts for 3 different characters, 3 different main characters. Once you have things in a table, you can visualize them. So I won't go through all the details of the code, but I started with the counts that I had. I then made a transformation, and then I did some rearranging, and then I made a plot, and you'll learn how to do all these things. But what's really important for today is to understand the data visualization that came out. And what this is the cumulative number of times that a name appears as you look farther and farther into the book. So starting at chapter 1, going all the way to, I think, chapter 43, how many times was Jim mentioned? Well, a lot, because he's the traveling companion of Huck, the main character in the book. And what about Tom? Well, now we see in a graphical form the fact that Tom was mentioned at the beginning because apparently he's important, but then he didn't show up until chapter 33. And then he was part of the action because he finally joined their crew. And then Huck here, the Adventures of Huckleberry Finn, and Huck, oh, strangely isn't mentioned much at all. Why might that be? Oh, someone put it in the chat already. So Huck is the narrator and it's written in the first person. So mostly it's I referring to Huck as opposed to the name Huck, and that's why it doesn't show up very often. So you have to be careful. If your goal is to figure out who's mentioned the most or who's doing the most in a book, and you assume that that's just the cumulative count, you might miss the fact that Huck is in fact a very important character, even though his name isn't mentioned very often. Okay, Little Women. This is basically the same code, except for now we're talking about a different book. And so here are the chapters. This is the name of the chapter. This is the title of the chapter, and Christmas won't be Christmas without presents. I think I'm just going to go through and draw the same chart because you saw the build up already. So I'll get the counts, and then I'll run a similar piece of code in order to get the counts. The 5 characters are 4 sisters, Amy, Beth, Joe, and Meg, and then their next door neighbor, Lori. Lori's a boy next door. And, I'd say these are the main characters. It's a book about 4 sisters, but one of them is kind of more heavily featured than the rest. And you can see from the chart who it is. Joe, I'd say, is the protagonist of this book, even though the other sisters are mentioned quite a bit. So you can kind of see that just by looking at the counts of names. That's cool. What else can you see? You can see something happened to Meg in the middle of the book. And so you could read the book in order to try to find that out. It doesn't really tell you what happened to Meg, but something might happen to Meg. You can even ask for more subtle things, like it turns out Lori, the boy next door, marries one of the sisters. Don't write anything in the chat just yet. Oh, you already did. Okay, so much for that. It's cool. So if you were trying to look at this chart and figure out which of the sisters Lori married, how could you tell? And one way is to read the book, of course. Well, another way is to look at the chat because it's there. But a third way is to identify some feature of this chart that tells you who Lori married. How could you tell? Well, think about it for a minute. And instead of typing it in the chat right away, why don't you say what part of the chart tells you who Lori married and how you'd know. And don't type it yet, but instead wait. And when I say hit return, then you can answer your question in the chat if you want. So you could type out an answer, but don't tell everybody yet. Let everyone just look at this chart for a little bit and see if they can figure out what is the feature here that tells you who Lori got married to. Okay, in 10 seconds, I'll let you put anything you want in the chat. 10, 9, 2, 1, go. Okay, I love it. So there are many votes for Amy. And why? How do you know that? Well, someone wrote, which line is most similar to Lori's? Well, what does it mean for a line to be similar? I mean, it's true that that Amy and Lori have about the same number of counts, and they sort of overlap a fair amount. So that's a nice indication, but Beth isn't that far off. So it would be really hard for me to choose confidently just based on the slope of the line or the fact that they end up at about the same place. Instead, the feature that really makes me notice what's going on is that they move together, that either neither of them are mentioned or both of them are mentioned. It's Lori and Amy, or Amy and Lori, over and over again, because they get married like right around here in chapter 36, and then the graphs move together. It's like true love in a graph, right? So I think that the kinds of things that you can notice in a data visualization extend beyond just, what's the slope of a line or how tall is some bar. Sometimes you can notice more interesting patterns than that. And that's why we use data visualization to explore data. All right, we got time for one more. I'll teach you about something you can do in Python, which you can get the length of something. What is the length of data 8? Well, what it's measuring, this is kind of something that's built into the programming environment, built into the Python language, is how many letters and spaces and numbers show up inside a piece of text. These are all called characters, not characters like Amy and Lori, but this is just like another meaning of the word character is that it's letters and numbers and spaces and things like that. So data 8, because it has that space, is 6 characters. And what about all of Huck Finn? Well, that's 588,000 characters. But we could do something more interesting than that. Instead, we could go through each chapter and count the number of all the characters and also count the number of periods in each chapter. So I know here's some code that you haven't learned what it means yet, but I will point out one feature, which is that we used length to figure out the length of data 8, and here we're using length again. So we're kind of using the same tools over and over again, just in a more complicated way. You'll get good at that. And so now we have the counts for Huckleberry Finn, and we have the counts for Little Women. And we are showing them as 2 tables, 1 row per chapter, the number of periods and the length. So you can see like the chapters aren't very long in Huckleberry Finn. They're definitely longer in Little Women. That's one observation we could make without a data visualization. But using a data visualization, plotting both books on the same axis, Huck Finn chapters are in blue, Little Women chapters are in gold. We can look at each chapter as a point in this plane where how far over it is the number of periods, how far up it is the number of characters. And we notice 2 things. Well, first of all, Little Women chapters are longer. The gold dots are over to the right. But also, it seems like the blue dots sort of fall on a line, and the gold dots, I think they kind of fall near a line too, and it's almost the same line. It's like, even though the chapters are longer in Little Women, there's some consistency with the slope of a line that you draw through the cloud, which is the ratio of the number of characters in a chapter to the number of periods. What does that mean? The ratio of the number of characters in a chapter to the number of periods? Well, that's the average length of a sentence that ends in a period. And what is that ratio? Well, if you look at like all the dots that are around 100 periods, they're about, 12,000 to 15,000 characters. You divide by 100 and you get about 120 to 150 characters per period for all the chapters in the book. Sometimes a little higher, sometimes it's a little bit lower, but it's true for both books. And what thing in the world relates to 120 to 150 characters per sentence? Does that remind you of anything? Twitter. Yeah, actually, when Twitter was first created, there was a 140 character limit on the size of your tweet. And then people got annoyed because they could only fit an average sentence in there. They couldn't fit a long sentence in there. And so they raised it to 280. So now you can kind of fit 2 sentences in a tweet. Okay, so that's the demo, just to show you the kinds of things we're going to work on and the importance of data visualization. Now you have to go learn how to do this yourself, which means go to lab. Welcome to Data 8. Final thoughts, Swapnil?
Yeah, super excited to have you guys. Thank you for keeping the chat lively. And we will see you at the first lab this week. Thanks, everyone.
Thanks, folks. Have a good day.